In the darkness of the universe, each star is a solitary beacon. It belongs to no one, yet it illuminates everything. From the moment it is born, it begins to burn, transforming hydrogen and time into light and warmth. This is the universe's most generous force. Every second, the energy it releases is enough to sustain countless civilizations. And we are just one of them. On Earth, light shapes everything. It drives winds and tides, allows plants to capture energy, and allows life to evolve in warmth. We breathe from the air it ignites. We eat from the energy it condenses. Even time itself is defined by the rhythm of light. We revolve around the stars, from day to night, from year to century. Light not only gives us life, but also gives us order and direction. We revolve around the stars, from day to night, from year to century. Light not only gives us life, but also gives us order and direction. From coal to oil, from nuclear power to light. Every leap forward in energy brings us one step closer to the stars. But desires also quietly expand. Our world is dotted with light, like a galaxy. But these lights also consume resources. We are beginning to realize that Earth's energy is running low. Humanity is beginning to look back at our home planet, the Sun. The energy it beams to Earth daily is tens of thousands times greater than our global consumption. If we only need to collect 1/10,000th of that energy, we can keep all lights on forever. So we built mirrors, laid out arrays, launched them into space, sent light harvesting machines into orbit. We thought we were imitating nature, but in reality, we were trying to replace it. At this moment, an idea occurred to me: what would happen if all the energy from a star could be collected? Imprisoning a star. It sounds like myth, like hubris. But it is precisely this delusion that makes us look up for the first time, and realize that energy is not just a need, it is also destiny. Perhaps, one day, we will learn to borrow the light of the stars, becoming no longer their servants but their partners. And the starting point of that day begins with a physicist's conception, an equation about stars and civilization. In the mid-20th century, humanity gained its first true understanding of its place in the universe. Satellites passed through the atmosphere, antennas pointed toward the stars. We began to listen outward and to ask ourselves, if there are intelligences older than our own in the universe, what are they like? Freeman Dyson, a physicist who hovers between theory and imagination. He's neither an inventor nor a dreamer, but with a piece of paper and a pen, he changed the way humanity looks at the stars. His vision is remarkably simple: if a civilization could construct a massive ring-shaped or spherical structure around a star, it would be able to capture nearly all of the star's energy output. Such a civilization would no longer be bound by a planet, but would instead coexist with the star. Later, Soviet astronomer Kardashev proposed the concept of civilization levels. He used energy to measure intelligence. Type 1, a civilization that harnesses planetary energy. Type 2, a civilization that harnesses stellar energy. Type 3, a civilization that controls an entire galaxy. The Dyson Sphere is the threshold to the second level. This is a vision derived from physics, and also a measure of ambition. We are beginning to ask not if, but when. He even suggested, we might be able to find those encased stars using infrared light. This is because trapped light no longer shines, but only leaks out as heat. He never mentioned building a solid sphere. Dyson envisioned a swarm of independently operating energy units, a floating network, an artificial nebula. Each module would collect light, and each beam of energy could potentially return to its parent star. It would be like an ecosystem, only on a stellar scale. In theory, all this is possible. The challenges lie in the materials, time, and willpower. But the power of thought lies in this: it doesn't have to happen immediately, it's enough to change direction. The birth of thought isn't the emergence of answers, but rather the expansion of perspective. Dyson made us realize that stars aren't just celestial bodies, they are the future of civilization. Since then, the term Dyson Sphere has become a lexicon of science and fantasy. For some, it symbolizes the limits of technology; for others, it represents a belief in civilization. And all this is just the beginning. When most people first hear the name Dyson Sphere, they imagine a giant metal shell, encasing the sun like a cage. But Dyson never intended for humans to create such a cage. A solid sphere cannot exist stably, it will collapse, vibrate, and eventually perish. A true Dyson sphere isn't actually a sphere, but a swarm. It's a group of independent energy collectors, distributed in orbit and spaced apart from each other. Imagine a honeycomb orbiting the sun. Each honeycomb is a separate energy collector. They could be satellites, mirrors, or photoelectric converters. They are not connected, yet they work together. Their common mission is to capture the light of the sun. The captured energy can be converted into microwaves or lasers and transmitted back to the parent planet via wireless transmission, or stored in orbital energy stations to sustain larger projects. This isn't waste, but a new form of ecological cycle. Energy flows from the stars and is absorbed by civilization. It's no longer just fuel, it's a cycle. But the dream of light requires material support. A Dyson swarm, even if it only captures 1% of the sun's energy, would require millions of orbiting satellites. They need materials, metals, carbon, silicon, rare minerals. Whatever Earth has is simply not enough. Therefore, the future Dyson swarm may be born outside of planets. Asteroid mining, automated construction, and then continued expansion by self-replicating machines. It's not a one-time project, but a growing ecosystem. As the population grows, the light of the star begins to flicker. This isn't a natural phenomenon, but a signature of civilization. In 2015, humanity briefly thought it had discovered such a signal, a star called KIC 8462852, its brightness flickering strangely. Some speculated it was the shadow of a Dyson swarm. Later, we learned it was merely dust and debris. But in that brief moment of doubt, humanity saw a reflection of its own future. Perhaps it would take thousands of years to build, perhaps it would never be complete. But the greatness of the Dyson swarm lies not in its completion, but in the fact that it allowed humanity to imagine for the first time, energy no longer needs to be scarce. Perhaps it would take thousands of years to build, perhaps it would never be complete. But the greatness of the Dyson swarm lies not in its completion, but in the fact that it allowed humanity to imagine for the first time, energy no longer needs to be scarce. The limits of technology are never the end, but rather a new moral starting point. The Dyson swarm is both a symbol of light and a projection of power. Someday, we might actually see it, a city of light orbiting the sun. It won't appear suddenly, but will begin with a tiny battery, a satellite. Like a seed, it will grow into the largest tree in the universe. What we build isn't just a machine, it's a way of being. Making the stars our home, making energy our language. We've learned to draw energy from the stars, but our true longing remains unchanged. In the long darkness, we still search for the light that perhaps already exists. The optical signal is invisible to the naked eye. We use infrared light to capture this excess heat. Searching for stars that are unusually dim but excessively warm. Perhaps it's the afterglow of some civilization. A Dyson swarm, still leaking warmth after billions of years. We mistakenly thought we had found it. A star called KIC 8462852, its brightness flickered, like it was breathing. For a time, some thought it was the shadow of a Dyson sphere. It turned out to be just cosmic dust. But the excitement of those years made us realize that humanity's desire isn't just discovery, but response. Our civilization has only been around for a few thousand years, while stars have lifespans of tens of billions of years. In the span of cosmic time, our existence is like a brief flicker. So, perhaps it's not that they were too quiet, but that we were too early. When we gaze at the stars, we are actually looking at ourselves. Earth's night lights, to other civilizations, may be a faint Dyson signal. We are our own signals, our own echoes. Perhaps, they have already seen us, and are simply waiting quietly. Waiting for us to learn to understand the language of light. Every observation is a letter sent to the unknown. We write coordinates with light, express our longings with signals. Perhaps one day, on some distant frequency, another breath will be heard. From another empire of light. Light is the carrier of civilization, the medium of culture and thought. Our story will continue along the journey of light. It may be seen by other civilizations, or perhaps it will simply be quietly preserved by the universe. As the relationship between civilization and the stars is written, as light is captured, transmitted, and understood, its final destination remains, flowing silently through deep space. Perhaps one day, other civilizations will understand us through light, and we, in turn, will understand the universe through light.